Hello there, Mr. Sutton here, bringing you the IM3 Honors 3-2 Part 2 homework solutions on adding and multiplying complex numbers.
To simplify this expression, I have to distribute this 6i. So 6i times negative 5 is going to give me negative 30i. 6i times negative 8i, that's going to be negative 48i squared. And I know I can simplify I squared to negative 1. So this is going to become a positive 48, and then we can write 48 minus 3i. To simplify this problem, we just have to distribute the 3i to this parentheses, and then simplify any powers of I that are higher than 1. So 3i times 6 gives us 18i. 3i times negative 8i, that's going to be negative 24i squared. Since I squared is really negative 1, this second term is really a positive 24 because you're doing negative 24 times negative 1. So we can write then 24 plus 18i, and by convention we always write the real number first. For multiplying these complex numbers, I'm going to start by FOILing this out, or just simply distributing everything in the first parentheses to the second parentheses. So we have 2 times 3 giving me 6, and then 2 times negative 4i, that's negative 8i. Negative 2i times 3 is negative 6i, and negative 2i times negative 4i is going to be positive 8i squared. So let's see, we can combine these i's in here. So we've got 6 minus, let's see, negative 8i minus 6i, that's negative 14i. And then this 8i squared, well, I squared is really negative 1, so this is really the same as having minus 8 out there. And then 6 minus 8, that's negative 2 minus that 14i. To multiply these complex numbers together, we're going to start by FOILing these out, just like we would with x's. So we have negative 6 times 4 is negative 24, and then negative 6 times 2i, that's negative 12i. 3i times 4 is going to give us plus 12i, so that's nice. And then 3i times 2i, that gives us plus 6i squared. So we have, let's see here, a negative 24. We've got some i's canceling out here. And then 6i squared, that's really the same as negative 6 because I squared is just negative 1. So when the dust settles, we've got negative 24 minus 6, and that's actually it after all that. And we can simplify that to negative 30. To multiply these complex numbers together, we are going to use FOIL. So we got 5 times 9 giving us 45, and then 5 times the negative 3i is negative 15i. Now we distribute the 6i to the second parentheses. 6i times 9, that's going to be a positive 54i. And then 6i times negative 3i, that's negative 18i squared. So we've got negative 15i and 54i can be combined. That's going to be positive 39i. We still have a 45 there. And this negative 18i squared, well, since I squared is really negative 1, this is a positive 18. And last but not least, 45 plus 18 gives us, that's going to be 63. So we have 63 plus 39i. To multiply these complex numbers together, we're going to have to FOIL. So we've got 3 times negative 4, that's negative 12. 3 times 6i is 18i. And then 8i times negative 4, that's going to be minus 32i. And then finally the lasts, 8i times 6i, that's 48i squared. So we have a negative 12. We have some i's that we can combine down here. So that's going to be negative 14i in the middle. And last but not least, we have a 48i squared. Now I squared is really negative 1, so we can think of this as negative 48. And then negative 12 minus 48, those can be combined to give us negative 60 along with the negative 14i. For this problem, we have to take the i's out of these radicals before we multiply anything together. So I'm going to rewrite this as 4i radical 2 times 7i radical 32. Now that we have positive radicands, positives inside the radical, we can multiply things together. On the outside, I've got 28i squared, and on the inside, 2 times 32 gives me 64, so then we have the square root of 64. And let's see here, I squared is negative 1, the square root of 64 is 8, So we can write this as negative 28 times 8. And let's see here, 8 times 28. Well, that's going to be, let me see, if I had 8 times 20, that would be 160. 8 times 8 is 64. 160 plus 64 is 224. So this is negative 224 if you did do it without a calculator. To simplify this product of these radicals, before we multiply things together, we have to actually take out the i's to get rid of those negatives inside. So this first one I'm going to rewrite as negative 2i radical 3. And this next one will be 6i radical 27. Now I'll multiply the stuff that's outside together, and I'll multiply the stuff that's inside together. On the outside, I have negative 12i squared. And on the inside, 3 times 27 gives me a radical 81. I squared is negative 1, so negative 12 times negative 1 is positive 12 on the outside. On the inside here, we got the square root of 81, which is 9, so we have 12 times 9, and then that's going to be 108. On this problem, we're told that x equals 3i, y is 2i, and z is m plus I. We want to know what the expression xy squared z comes out to. So let's see here. Plugging things in, we've got 3i times 2i squared times m plus I. So just be careful to use parentheses when you plug all these things in. It won't matter much on the 3i, but the 2i needs to be in a parentheses, as does the m plus I. All right, let's next take care of this exponent here. Exponent happens before multiplying and adding. So 2i squared, that's really going to be 4i squared. And let me multiply the 3i and the 4i squared together. That's going to be 12i cubed. And at this point, you actually could have turned this into a negative 4, but I guess half a dozen of one, 6 of the other. Speaking of a dozen, we have 12i cubed out here. Let me just distribute that. So that's going to be 12i cubed m plus 12i to the 4th. And now we're going to simplify our powers of I, because you'll notice none of the answer choices have I to any kind of power other than 1. So I cubed, we know that's negative I. So this first term can be written as negative 12i m. And then this next term, I to the 4th, is really the same as I to the 0, because it starts over every 4 with the I exponents. So this is really just going to be 12. So we then end up with 12 minus 12im. And that's going to be answer choice C.